Hey guys, welcome. This is our 2-1-2-2 review video. Basically, I'm going to be going over this worksheet in preparation for our quiz tomorrow. So, first thing it says, find a pattern for each sequence. Use the pattern to show the next two terms. Our numbers are increasing here, and so what I like to do is I like to literally show what's happening. So this looks like I'm adding 6 from 5 to 11, and then it looks like I'm adding 7. And then it looks like here I'm adding 8, so I'm assuming I'm going to add 9, and then I'm going to add 10 after that. Okay, so it's 26 plus 9, that's going to give me 35, and then I'm going to get 10 plus that, which is going to give me 45. So those should be my next two numbers in my sequence. Okay? Alright, this next one's kind of tricky. AB, notice C is gone, so C is missing. DE, F is missing, so it looks like every two letters I'm skipping one. So G, H, it should be I, but we're going to skip I, so then I'm going to get J and then K. So we skipped, it looks like every two, then they skip one. Alright, next we got -3, 6, -2, 24, -48. It appears we're multiplying by -2 each time. So that's a multiplication of a -2. As we continue through this. So I'm going to take 48, and I have my calculator, I don't want to make a mistake here. 48 times 2, -2, I apologize. It's going to give me a positive 96, and then again multiply that by 2, that's going to give me a negative 192. Okay. Alright, next one we got 1 to 5, 5 to 30, 30 to 210, and 16 to 180. One second, let me go ahead and I gotta zoom this in. I think it's a little too small. Okay, here, I zoomed it in. Alright, so right here, it looks like from 1 to 5, then 1 to 30, it can't be adding, but it looks like maybe multiplying. So multiplying by 5, from 5 to 30 is going to multiply by 6. This looks like it's going to multiply by 7, by 8. So we're multiplying by increasing numbers, so we're going to get 1680 times 9, which is quite a large number, 15,120, and then we're going to multiply that by 10, which is going to be 151,000. So those would be our two numbers right there. Okay? You can't see those, sorry about that. So I went multiply by 5, 6, 7, 8, 9, and 10. Okay? Alright, make a conjecture for each scenario, show your work. Okay, so we're making a conclusion for each of these. Okay? The square of an odd number. Alright, so we need to make a conjecture for that. In order to do conjectures, we want to think about what happens if I square an odd number. Okay, so let's do 3 squared. What do I get? I get 9. Let's try another one. Let's do 5 squared. I get 25. I'm going to do, let's see, 7 squared is 49. What it looks like is happening, 9, 25, and 49, when I square an odd number, I get an odd number. Okay, so my conclusion or my conjecture is the square of an odd number is odd. Okay, so that's what I get. It's going to be an odd number. So we just try things. So 12, the cube of a negative number. Okay, so -2 cubed, that's the equivalent of negative, let's put parentheses around that, -2 times -2 times -2, that's a -8. -3 cubed, that's going to be 3 times -3 times -3, which is a positive 9, times a -3, which is a -27. So it looks like whenever I cube something that's negative, it stays negative. So the cube of a negative number is negative. Okay? Again, to make a conjecture, we're just looking at the question, we're doing it, and seeing what shows up, what frequently happens, and that's how we come up with our conjecture. It's basically our conclusion. 13, the product of two even numbers and an odd number. Okay, the product of two even numbers and an odd number. Okay, so let's do 2 times 2 times 3. So 2 times 2 is 4, 4 times 3 is 12. Let's do 4 times 4 times 5. Okay, 4 times 4 is going to give me 16, and then 16 times 5 is going to give me 80. Okay, it looks like I'm getting even numbers, so I think that's my answer. The product of two even numbers and an odd is even. Okay, so I'm going to get an even answer. The product of a multiple of 5 and a multiple of 2. So we could just do 5 times 2, that's 10. We could do 25 times 4, which is 100. Let's do one more. Let's do 30 times multiple of 2. Let's do 30 times 8, and we'll get 240. Okay. It looks like our answer is going to be even. We could even maybe say is divisible by 10, because it's a product of 5 and 2. It's going to be also divisible by 10. So I would say even, or maybe divisible. Divisible. Sorry, I spelled that wrong. By 10. Okay, so again, it's just trial and error on those. Okay, I might have to zoom out a little bit for this one. Sorry about that. We have inductive reasoning to predict our scenario. Hannah sells snow cones during soccer tournament. She records data for snow cone sales and the temperature. So we have our temperature here and the sales of our snow cone. Predict the amount of snow cones when the temperature is 100. Okay, so I don't have any data at 100, but I'm assuming it's going to be somewhere around here. Okay, so it's going to be somewhere around there. So I think these are sales and something that got cut off, but I'm assuming it's going to be somewhere up here. So I'm going to say probably 5. Okay, she's going to probably make 5 sales or so when it's 100 degrees. Is it reasonable to use the graph to predict sales from the temperature is 15 degrees? Well, 15 degrees is going to be way down here. And I'm going to say no, because at 15 degrees, people probably aren't going to want snow cones. It's too cold. So we're going to say no, because it is too cold for snow cones. Who wants a snow cone in 15-degree temperature? Not me. Not me. Okay? All right, moving up, our last 3 for this page. We got the sum of 2 integers is always positive. We're trying to find a counterexample, something that disproves this. Okay, a sum of 2 integers that's always positive. Okay, well, here we go. -2 plus a -3. That equals a -5. All right, is that positive? No. So this is a good example of a counterexample. Okay? We're not finding an example that works, we're finding something that disproves the statement. The product of 2 mixed numbers is never a whole number. So I want to think, what 2 numbers that are mixed numbers would actually multiply to each other and make a whole number? Okay, so we got to think about that one for a second. Okay, so after a little thought, I actually paused the video and thought about that for a second. Mixed numbers are numbers like, say, let's say 2 1/2 times, let's say, 2/5. Okay, so we have some mixed numbers, right? And what we actually see here is when we multiply these two, we could actually turn this into 5/2 times 2/5. These actually cancel with one another and make 1. So 1 is a whole number, even though we started out with mixed numbers. So here's another good counterexample for that one. All right, last one on here. It says all four sided figures are rectangles. Well, here's a different example here. I kind of drew that weird. Let me try that again. I apologize. I want to do that. There we go. That's a four-sided figure right here. Let me move it up. That's a four-sided figure. Clearly not a rectangle. For a rectangle to have all 90-degree angles, and this does not. Okay, let's flip it over to the back. All right. I like these ones here. So this is from 2-2 side. It says identify the hypothesis and the conclusion. So I'm actually going to do this in 2 different colors. So I'm going to go ahead and just highlight here. hypothesis comes first, it's blue, and then yellow is our conclusion. Okay? So if a number is divisible by 2, so it's if you see the if, that's our hypothesis, then the number is even. That's our conclusion. Okay? The sidewalks are wet if, then it has to be raining. Okay? So again, hypothesis comes, then conclusion. Number 5, a regular pentagon has exactly 5 congruent sides. All we have to do is put this as a conditional, which means we want an if-then statement. So if a regular pentagon, then it has exactly 5, and I can see I'm running out of space here, let's move it over, congruent sides. Okay? Next it says 2 complementary angles form a right angle. Okay? So we can say if, okay, the if and then is our key, right? From the last one. If 2 complementary angles, then they form a right angle. Okay? So again, if and then, that's our important pieces to this. Number 9, write a conditional statement that each Venn diagram illustrates. The inside is our P, the outside is our Q. Okay? So that means that we're always going to start with our conditional, our hypothesis on the inside, and then work out. So let's go ahead and do this. So if Italian, then a Romance language. Okay, and that's true. If Italian, then it's a Romance language. Next, if a square, then a rhombus. Again, this is true. Okay, if you have a square, then it's a rhombus. Does not work the other way around. Number 11. If the figure has 4 congruent angles, then the figure is a square. Okay, so we're going to say true or false. All right, I'm going to say false. Okay, and I could have a pentagon. A pentagon has 4, actually has 5 congruent angles. So it didn't say only 4, it just said 4. And a pentagon does have 4. If an animal barks, then it's a seal. False. Dog. There's my counterexample, right? A dog definitely does not have these. Okay? Alright. And these are the ones we want to spend our time on. Okay? And since we're running out of time on this video, let's go ahead and we'll go make the second video and make sure we get all these down. Okay? So we'll see you in part 2.